Matrix matching. Column 1, 4 graphs are given to us. In column 2, 4 options are there. Distance covered is longest in a given time if the distance time graph is not parabolic. Second part, it's retardation. Third, velocity increases linearly with time and acceleration is constant. So, we will take one by one all the options or all the graph and study in detailed manner, and then finally we'll see which all options are correct for option A. So first I'll take option A. The acceleration time graph is given. Now this acceleration time graph is increasing with time. This is the slope of the graph. Slope of graph is constant. So what are we conclude from this part? Slope of the graph is constant. Acceleration is increasing with time. So when acceleration is increasing with time, velocity increases, but not linearly. It will go on becoming more and more rapid. Distance covered is longest because it's ever increasing graph. Distance covered is longest in a given time. So if the displacement time graph is not parabolic, so here will not be a parabolic. It will go on going on increasing. Distance covered will be going on increasing or becoming more and more. These are the points we concluded. So what will be the correct options for all these things? For these points, let us look into. Distance covered is longest in a given time. Displacement time graph is not a parabolic. So this will be the correct option. Retardation. No, here there is an acceleration. Velocity is increasing linearly. In this case, velocity is not increasing linearly. Acceleration is constant. It is ruled out. So what finally we conclude? For option A, we have only one, and that is P. Correct? Now let us see the second graph. For B part, the graph is a straight line. So acceleration time graph is a straight line. So in this case, what we conclude? Acceleration is constant. That means velocity will increase with the time. Acceleration is constant. Whatever the acceleration it is having the same acceleration will be there. Constant acceleration, the body will move. Distance will be covered. Distance covered will be positive. So let us now look into what are the correct options which we can have. So for this graph, distance covered is longest. This may not be the correct. Retardation, this is not correct. Here velocity increases linear with time. Right. Acceleration is constant. This is also right. So for option B, we have R and S. So for option B, we have R and S. Both the options correct. For the third graph. Now here it's a velocity displacement graph. Every time the slope of the graph is decreasing, you check the tangent drawn at every point. So every point the slope of this curve is decreasing. What does it indicate? dv by dx, because the velocity is a function of x. That is tan theta. Slope. dv by dx decreases. So acceleration A is v dv by dx. So when dv by dx decreases, that means acceleration is decreasing. What we call decreasing acceleration? That is called retardation. When it is retardation, velocity will decrease linearly. Velocity will decrease and acceleration is not constant with time. So let us see what are the options which are correct. So for third graph, distance covered is longest. No, here the distance covered will be less because the body is going to come to rest. Retardation, Q option is the correct one. So for C, Q option is correct. Velocity increasing linearly, that's wrong. Acceleration constant, that's wrong. So correct option will be for C is Q. For C, it is Q. Let us see the fourth graph, graph D. In this time, kinetic energy versus X is given. So kinetic energy is proportional to X according to the graph, because this graph is having a definite slope. Kinetic energy half mv square proportional to X, or we conclude V square is proportional to X. We can write simply V square is equal to Kx. Now let us differentiate it. 2V dV by dt is equal to K times of dx by dt. What we have done? Differentiated with respect to time. 2V dV by dt is equal to K into V. So we can cancel this point. 2 we can take it here. dV by dt is equal to K by 2. That is constant. What is dV by dt called? dV by dt is acceleration. So acceleration is constant. So one conclusion we get, acceleration is constant. and it's increasing velocity, so it should be positive acceleration. So velocity increases linearly, correct? So what are the conclusions we are going to get? Just look into this. Fourth graph, kinetic energy versus x. Distance covered is longest. So acceleration is constant, velocity increases linearly. Since acceleration is not increasing, therefore this option may not be correct option. Retardation is wrong option. Velocity increases linearly with time is the correct option. Acceleration is constant is also correct option. So for D, R and S option both are correct. For D, we have R and S. So final conclusion, for A, option P. For B, option R and S. For C, option Q. And for D, option again R and S. So this will be the final answer for this particular question.